Now that we've got a general idea of what exponential functions are, we're going to actually look at exponential models. So we know that an exponential function needs to be in the form of f of x equals a b to the power of x, where a can't be, it can't equal 0, and b has to be greater than 0, but it also can't equal 1. So when we're looking at this, a is called our initial value, and b, depending on whether we're growing or decaying, this is what we call our growth factor or decay factor, whichever one. Whichever one happens to be the case. So like I said, we were talking about, in the other video, we were talking about, exponential decay, exponential growth, and one of the examples I had used was talking about bacteria. So with that, sometimes you will be given information and you'll have points that are given and you're supposed to write an exponential model. And we want it to be in the form of f of x equals a times b to the power of x, because that is our exponential form. But so we've got some points here and we're supposed to figure out our exponential equation just based on that. You can do this by hand or you can use your graphing calculator. So the first thing I'm going to show you is how to do this by hand, and then the next example I will show you how to use your calculator. So with that, we know that when we have f of 3, that it equals 20. We also know when it's f of 5, this equals 40. So there's some things that we can do in order to solve for this. We know then that this is in the form for the f of 3, 20 equals a times b to the third, because our x's have to match, hence the 3. And we know over here on the right that this has to be 40 equals a b to the fifth. So with this, we can set this up in order to figure out our equations. So we're going to take our second equation, our 40 equals ab to the fifth, and divide it by that 20 equals ab to the third. So when I do this, I get 40 divided by 20, gives me 2. The a's would cancel out, and our b's here would go down to b squared, because property of exponents, we know that we would subtract those exponents to give me 5 minus 3 to give me 2. So with this, I now have an idea here that b has to be the square root of 2. So now from here, I can go ahead and figure out the a value using that b. So I know that 20 equals a times the square root of 2, and we know it's cubed. So from here, I can solve for a then. If I was looking at this, so I'm going to get 20 equals a, and I went ahead and did the square root 2 to the power of 3, and it's going to be an estimate, which is fine. Let's go with 2.828, and then I go ahead and divide that then. And a here is going to be roughly 7.07. So now I can write my equation. F of x equals 7.07 times square root 2 to the power of x. And just as a double check, you can plug in that 5 just to make sure that you get the same answer, and it should be 40. And we know that because we've already we already know that it's going to be 40. And we get, if I were to plug in that 5 just as a double check into the x, I get 39.9939, so we would round that up to 40. So we know that our exponential model works here. Now, like I said, this is calculating it by hand. But let's say that I have a bigger model here in which I have more points that I can work with. I can actually do this using the calculator. So I have these points here that I'm going to go ahead and plug into my graphing calculator. So I'm going to go to Menu, I'm going to go to Add List in Spreadsheets. I always just like to stick with the X and Y, you guys know that by now. So my X values are going to be the number of people. My minutes are going to be my Y values. So going back here to 3, 4, 5, 6, 7, 8, 9, and 10. My Y values are 2, 2.6, 3.4, 4.4, 5.7, 7.4, 9.7, 12.5, and 16.3. So just to get an idea here of what this actually looks like, just so you guys can see it here, if I were to add my variable, if you look at these points here, you can see that there's going to be an exponential here. Okay, and so what we're going to do here is we're going to find an exponential model. You can do this from your data and statistics screen or from your list and spreadsheets screen. I'll show you from the data and statistics as well as the list and spreadsheets. So if I'm in my list and spreadsheets, I need to click on Menu, Statistics, Stat Calculation. If you notice here, we have all kinds of options for different types of regression, and we're going to go with an exponential regression. My X list we know is my X, and my Y list is my Y. I'm going to hit OK. And notice here, I have it, and you can tell that it's in the proper exponential form because it's a times b to the power of x. Gives me an a value, it gives me a b value, as well as it gives me a correlation coefficient. So I know how well this line is going to hit through my data. If you're on this one, you're going to hit Menu, Analyze. When you're doing regression, you're going to hit exponential. And it's the same exact equation that we had in our list and spreadsheets. This one is just right from our actual graph here that you guys can see. It just depends on which preference you prefer. It's pretty much the same kind of action. You go to Menu and then you go through there to get to your equation, your regression line. So that would be our exponential model for this. Like I said, you could calculate this by hand if you wanted to. You just have to pick 2 points that when you draw your line that fits through it the best.